Now we are going to start our next lecture of class 10th mathematics, chapter 1, real numbers. So this is lecture number 2, and in this we will talk about the fundamental theorem of arithmetic and solve problem based on LCM and HCF. Now the fundamental theorem of arithmetic, it says that every composite number can be uniquely expressed as product of primes except for the order in which these prime factors occur. So in our previous classes we have studied the definition of prime and composite numbers. So we are saying the prime numbers are those numbers which have exactly two factors, and composite numbers are those numbers which have more than two factors. These are basically the properties of natural numbers we are talking about. So one is neither prime nor composite. So if we are talking about the natural numbers 1, 2, 3, 4, 5 and so on, then we are saying 1 is neither prime nor composite, 2 has factors 1 and 2, 3 has factors 1 and 3, 4 has factors 1, 2, 4, 5 has factors 1 and 5. Similarly, if we talk about 6, it has factors. If you look at the factors of 6, it is 1, 2, 3, 6. So what we are saying, 1 is neither prime nor composite, 2, 3, 5, these numbers, these have two factors, these are the prime numbers. If I am talking about 4, it is 1, 2, 4, 6, it is 1, 2, 3, 6. So these numbers, these are composite numbers. So we are saying every composite number can be written uniquely as the product of primes except for their orders. So some examples are given over here. If I am talking about 12, so 12 we can write it is 3 into 2 into 2, or you can write it as 2 into 3 into 2, or you can write it as 2 into 2 into 3. So what this definition is saying, that if I am talking about 12, we can write it like 2 raised to the power 2 into 3, or I am saying it is written as a product of prime numbers. Order of these prime number means we are talking about 3 is written over here, here or here. It is, we are not looking at the how these numbers are written, but the numbers that are unique over here. That is, if I am writing 12 as the product of prime, then 3 numbers I have, it is 3, 2 and 2. Similarly, if I am talking about 69, it is product of 2 prime numbers 3 and 23. 105 we can write it is 3, 5 and 7. So how we can look at these values over here? If suppose I am talking about the factors of 105. So how we can find the factors is, I am talking about the prime factors. Prime factor means I will start with the number 2. 105 is not divisible by 2. Next I will look at the number 3 over here. So I am saying it is 3 over here. So if I divide these two values, first of all I have to check whether 105 is divisible by 3 or not. We know that it is 5 plus 1, the sum of all these digits, it is 6, it is divisible by 3. So we are saying it is 3, 3s are 9, 10 is there, so 1 we are left with, and 3 5s are 50. Now 35, it is not divisible by 3. So we come to the next point, prime, it is 5. So we divide it with 5 now. 5 is the factor of 35. So it is 7 5s are 35. And now we cannot factorize 7 is a prime number. So we get 1 over here. So we are saying the prime factors of 105 there. We are talking about it is 3, 5 and 7. So we are writing 105 is equal to 3 into 5 into 7. Similarly, in the case, suppose I am talking about 4, 6, 2. So I am talking about 4, 6, 2. This is an even number. It is divisible by 2. So it is 2, 3, 1. Now this number is not divisible by 2. So the next number we are talking about, next prime, it is 3. So if we look at the divisibility with 3, it is sum of these numbers, it is 6, so it is divisible by 3. And the answer we are left over here, it is 3 7s are 21. It is 2 is left over here, and 3 sevens are 21. Now 7 plus 7, it is 14, and it is not divisible by 3. So next we will look at the divisibility with 5. This number, the last digit is not 5, so it is not divisible by 5. It is divisible by 7, and 7 11s are 11 and 1. So the numbers we obtain over here, it is 2 into 3 into 7 into 11 into 1. 1 we are not writing because we are mainly interested in the prime numbers, and we know 1 is neither prime nor composite. So 4 6 2 we can write it is 2 into 3 into 7 into 11. Similarly, these numbers we are talking about, that 2 3 4 you can write it is 2 into 3 into 3 into 13. This 6 5 1 you can write it is 3 into 7 into 31. So I am again talking about the fundamental theorem is saying that every composite number can be expressed as product of primes except for the order in which these prime factors occur. Order in which means we can write it like 31 into 7 into 3 also. But these are the three numbers that we are talking about, that these are the three prime factors. Now next is we have to show that the following numbers are composite numbers. So to prove that the numbers are composite, it means we have to show that they have more than the two prime factors, or more than two factors we are saying. So more than two factor means that the number itself and 1, they are always the two factors that we have for all numbers greater than 1. So we have to show that there is some other factor also. So the number that is given to us is 5 into 11 into 13 plus 13. Now if we look at this number over here and we take 13 common from both these, so what we are left with is 5 into 11, 13 we have taken common. From the next, when we will take 13 common, we are left with plus 1, because it is 13 into 1 over here. We are saying this is 13 into, it is 55 plus 1, that is equal to 13 into 56. So we are saying that whatever the number is, its factor will be 1, its factor will be number itself, its factor is 13, its factor is 56, and all the factors of 56 are also the factor of this number. So what we see from this is that it has more than two factors. It means it is a composite number. Similarly, in the next problem, we are talking about it is 6 into 5 into 4 into 3 into 2 into 1 plus 5. So what we have over here is 5 is there, this 5 is there. If we take 5 common from both these, this 5 we have taken common from both these, so we are left with this 6 into 4 into 3 into 2 into 1. This is 5 into 1 over here. When we take 5 common, we are left with this 1 over here, and we are getting it is 5 into 145. It means whatever this number is, it has more than two factors. It means it is a composite number. The next question we have is, show that any number of the form 4 raised to the power n can never end with the digit 0. It can never end with the digit 0. So for this we are saying if a number is ending with the digit 0, it means 5 will be one of its prime factors. I am talking about any number is there, say 10 is there, say 30 is there, say 100 is there. So what we see is, for all these numbers, 5 will be a prime factor. Now if we look at the numbers of the form 4 raised to the power n, it means their prime factors. If I am talking about, then 4 raised to the power n, we can write it is 2 raised to the power 2 raised to the power n. It is 2 raised to the power 2n. So the only prime factor of these numbers, it is 2, and 5 is not a prime factor of these numbers. So we are saying that 4 raised to the power n cannot end with the digit 0, because we need 5 as a factor. We are not saying that if 5 is a factor then the number is divisible by 10. One thing that is important to mention over here, if suppose I am talking about 25, its factor is 5, but it doesn't mean that it is divisible by 10. So these kind of conditions, these are called necessary and sufficient condition. We are saying that if a number is divisible by 10, then 5 must be its factor. We are not saying this thing that if 5 is a factor then it is multiple, then that number is divisible by 10. Similarly, in the next, it is show that any number of the form 6 raised to the power n, where n is an natural number. This is the symbol for belongs to. This comes from set theory. You have not studied set theory, but you should know this symbol is belongs to symbol, and n is the symbol for the natural number. So belongs to means that n is from the collection of natural numbers, that n is a natural number. So can never end with the digit 0. So again, if we look at this value over here, it is 6 raised to the power n. It is 2 into 3 raised to the power n. Both these numbers, these are positive, so it is 2 raised to the power n into 3 raised to the power n. So the prime factors over here, they are 2 and 3. Again, 5 is not a prime factor over here. So what we are saying is that 6 raised to the power n can never end with the digit 0. The same thing we are talking over here, that 6 raised to the power n can never end with the digit 0. Now the next question we have is find the LCM and HCF of 126 and 156. So HCF, the definition of HCF that we have already seen, that HCF means highest common factor. LCM, you know, the definition is least common multiple. Now with this example, it will be more clear to you that what is the meaning of both these terms. So first of all, we are going to find the factors of both these values. So to calculate the factors, suppose I am talking about the factors of 126 and 156. I am talking about the prime factorization of these two. It is divisible by 2. It is 6 over here, so it is divisible by 2. So the answer we are left over here, it is 63. Next, again it is divisible by 3. In the next step, we are saying it is divisible by 3 because it is now not divisible by 2. But if we look at these two values, it is 6 plus 3 is 9 and 9 is divisible by 3. So it means this number 63 is divisible by 3, and the answer we will get over here, it is 21. Next, it is again divisible by 3 and the answer is 7, and 7 we know it is divisible by this. Same thing is shown over here in this diagram. The same thing is shown over here, that these values 2, 3, 7 and 1, and these are the values we are talking about. It is 63, 21 and 7. So these are two ways to write these values. So it is up to you that how you want to factorize these numbers. Similarly, for 156, we are saying the first it is divisible by 2. So we are left with it is 78. Again it is divisible by 2. We are left with it is 39. It is not divisible by 2. It is divisible by 3 and it is 13 over here. So if we write these numbers, we are writing it is 126. You can write it as 2 into 3 into 3 into 7. And when we are writing 156, we can write it as 2 into 2 into 3 into 30. This value in the compact form, you can write it as 2 into 3 raised to the power 2 into 7. And this value you can write it as 2 raised to the power 2 into 3 into 30. So if we look at the HCF of these two numbers, then we are saying the HCF, how we will calculate? Talking about the HCF. One method we have already studied in our first lecture. This is the second method, that is using the prime factorization we are talking about. So how we write the HCF is, We write the product of the common terms with lowest power. The HCF of these two numbers will be product of the common terms with the lowest power. So the common terms over here, if we look at the common terms over here, it is these values I am talking about. 2 is there, 3 is over here, but 7 and 13, these are not common terms. So first of all, what we are going to do is we are going to write the common terms. 2 and 3, these are the common prime factors that we have. Now we have to put the powers of these two terms, and the powers we have to put is the smallest power. Now if we look at the power of 2 over here, if you look at the power of 2 over here, it is 2, and power of 2 over here, it is 1. So lowest of all these values, it is 1. Now look at the power of 3, it is 2, power of 3, it is 1. So the lowest value, it is 1. So the answer we will get, it is 6. So 6 is the HCF of these two values, that is the highest common factor. Next, when we have to write the LCM of these two values, when we are talking about the LCM of these two values, we are saying what we have to do, we have to write the product of prime factors with highest power. Basically what we are doing over here is that in this case we are saying there is a factor 7 with power 0, and this is the factor 13 with power 0. So when we are talking about the lowest power, so lowest power of 13 is 0, lowest power of 7 is 0. When we are talking about the LCM, we are saying the prime factors we have, it is 2, 3, 7 and 13. And what are the highest factors? Powers. Highest factor power of 2 is 2. Highest power of 3 is 2. Highest power of 7 is there over here. Its power is 1. Highest power of 13 is 1. So the answer we get, it is 2 raised to the power 2, 3 raised to the power 2 into 7 into 13, and the answer it is 3276. This thing will be more clear to you with our next example. Now we have to find the HCF and LCM of 612 and 1314. So the first thing we have done is we have done the prime factorization over here, that you can try now at your own. This is the prime factorization of 612, and this is the prime factorization of 1314. So from this prime factorization, what we get is that we can write 612 is equal to 2 raised to the power, I am talking about the number 612, we can write it is 2 raised to the power 2 into 3 raised to the power 2 into 17. It is 2 raised to the power 2, 3 raised to the power 2 and 17. Similarly, the second number we are talking about, it is 1314. We can write this is equal to 2 into 3 raised to the power 2 into 73. Now you need not to write this, I am just writing it to make the things more clear. I am talking about, I can write for 612, I can write it is into 73 raised to the power 0. I can write this term in this, and I can write 17 raised to the power 0 in this. So what we see from this, what are the common factors now? The common factors now, it is 2 into 3 into 17 into 73. I am again talking about this value. The common factors now we have, it is 2 into 3 into 7 into 73. Now when we have to write the HCF, for writing the HCF, we are saying what we are going to do, we are going to write the product of common terms with lowest power. We are going to write the product of common terms with lowest power. So lowest power means, if I will look at the power of 2 over here and here, the lowest power we have, it is 1. The lowest power of 3, in both these cases it is 2. The lowest power of 17, it is 0 and it is 1. So basically it is 0. Lowest power of 73, it is 0. So we need not to write these terms over here. We are just saying that the lowest power of these values that we have, that is 0. So HCF of these two numbers, it is 2 into 3 raised to the power 2, that is 2 into 9, that is equal to 18. Next we have to write the LCM of these two numbers. So for LCM we are saying we have to write all the prime factors and their highest power. So highest power for 2 it is 1, highest power for 3 it is 2, highest power for 17 it is 1 over here and it was 0 over here. So 1, and for 73 it is 1, and when you will multiply these values you will get the answer is 44676. So this is the LCM of these two numbers. Now next a result is given to us, that is product of two given numbers and product that is equal to the product of their LCM and HCF. It means we are talking about that 612 into 1314, the product of two numbers, that is equal to 18, that is LCM, into 44676 HCF and LCM, product of HCF and LCM of these two numbers. So what we are saying is that A into B is equal to HCF of AB into LCM of AB, and it is important to note that this result is true only for two numbers. This result is true only for two numbers, that is if two numbers A and B are given to us, then the product of these two numbers, that is equal to HCF and LCM of these two numbers. So next it is given that the HCF of two numbers is 23 and LCM is 1449. If one number is 161, find the other number. So we have seen this result that A into B is equal to HCF of AB into LCM of AB. HCF is 23, LCM is 1449. The number that is given to us, it is 161. So we substitute in this formula that 161 into B is equal to 23 into this. So the value of B that you will obtain, that is equal to 207. Similarly, in this next question we are given that HCF of two numbers 252 and 594, HCF of these two numbers, it is 18. You have to find the LCM. So it means two numbers are 252, 594, their LCM is 18 and we have to find the HCF is 18 and we have to find the LCM. One important thing to note over here is that HCF is always smaller than both these numbers and LCM is always greater than both these numbers. So what we get is that LCM, that is equal to 252 into 594 upon 18, and when you will solve this value you will get it is 8316. So another result that we have seen over here is that if A and B are two numbers, then HCF and LCM of A and B we are talking about, then HCF is less than or equal to A and B. It is less than both these numbers, and LCM is always greater than equal to A and B. It cannot be less than both these numbers. Next is find the simplest form of 148 over 185. So to find the LCM of both these numbers, what we have done, we have divided 185 by 148. It is 1 and it is 148. The remainder we are left with is 37. So next step we have to do is we have to divide it with 148 with 37, and when we divide this we get it is 4 is 148 and the remainder it is 0. So what we can say is that 37 is the LCM of 185 and 148. HCF of 148 and 185, it is 37. So it means that 37 is the largest number that can divide both of these. So when we divide 148 with 37, we will get it is 4 is 148, and when we will divide 185 with 37, we will get it is 5 is 185. So we are writing 148 is equal to, we are dividing the numerator and denominator by 37, and we are getting the answer is 4 by 5. That is the simplest form of the given fraction. Next is we have to find the HCF and LCM of these three numbers. The procedure is same. The first step we have to do is we have to do the prime factorization of all these three numbers. So it is shown over here, the prime factorization of 108, then next prime factorization of 120, and then next the prime factorization of 252. So after this what we see is that 108 we can write it is 2 raised to the power 2 into 3 raised to the power 3. It is 2 raised to the power 2 and 3 raised to the power 3. 120 we can write it is 2 raised to the power 3 into 3 into 5, and 252 is equal to 2 raised to the power 2 into 3 raised to the power 2 into 7. Now first thing we have to calculate is the HCF. So common factors in all these three, it is this 2 is the common prime factor, 3 is the common prime factor, 5 and 7 these are not the common prime factors. So what we get is it is 2 into 3. What is the lowest power of 2 over here? It is 2. And what is the lowest power of 3 that we have? It is 1. I think the lowest power of 3 that we have it is 1. So the HCF that we will get, it is equal to 12. Next is LCM. For LCM we are saying we are having the factors 2, 3, 5 and 7. Highest power of 2 we have it is 3. Highest power of 3 that we have it is 3. Highest power of 5 we have it is 1. Highest power of 7 we have it is 1. And when you will multiply these values, you will get the answer 7560. So the LCM of these two numbers, we are saying it is 7560, and HCF of these two numbers, it is 12. Next question is find the largest number which divides 245 and 1037, leaving remainder 5 in each case. So suppose we are saying the number that we are talking about, it is say A or B we are saying, because B is the number we are talking about. So if we divide this B with the 245, we will have some quotient. We are saying it is into B, and the remainder we are saying it is 5. So what we get is that Q into B, that is equal to 245 minus 5, that is equal to 240. So what this thing means is that B divides 240. Similarly 1037, that will be equal to some other quotient. B is the same number we are talking about. Remainder that should be left, it is 5. So it means Q1 into B is equal to 1037 minus 5, that is equal to 1032. It means this number B will completely divide 103. So the question that we have, it is find the largest number which divides this and this, leaving remainder 5. It is now changed to, we have to find the largest number which exactly divides 240 and 1032. We are talking about, we have to find the largest number which divides both these numbers, and this is the, we are talking about largest number which divides both 240 and 1032, and this is the definition of HCF. It means what we have to do, we have to find the HCF of 240 and 1032. So HCF of these numbers, you can find the HCF of these numbers. We have calculated the prime factors for both these numbers. From this, what we see is 240 can be written as 2 raised to the power 4 into 3 into 5. 1032 can be written as 2 raised to the power 3 into 3 into 43. So HCF will be, we are saying the common factor, it is 2, this is 3. So we have written 2 and 3, and the lowest power of 2 is 3. The lowest power of 3 is 1. So the final answer we will obtain, it is 2 raised to the power 3 into 3, that is equal to 24. So we are saying 24 is the number which, when divided by 2, 4, 5 and 1037, leaves the remainder 5. It is the largest number that we were calculating. The next is find the largest number which divides 129 and 545, leaving remainders 3 and 5 respectively. So again we are talking about that suppose the number we are calculating, it is B. So on dividing with 129, we are saying suppose the quotient is Q1, we are saying we have multiplied the number B and the remainder it leaves, it is 3. The number 545 we are talking about, quotient is Q2 into B and the remainder is 5. So what we get is that Q1 into B should be equal to 126. Q2 into B should be equal to 540. So the question becomes, our question becomes, find the largest number which divides 126 and 540. This means our problem is to find HCF of 126 and 540. We have already seen one method to find the HCF. You can use this method also, or you can use the previous method also. So you can use any one of these methods that you have calculated the prime factors of both these numbers. For 126 and 540, we have calculated these are the prime factors. Then the answer we are writing, it is product of the common terms with the lowest power. This is HCF is the product of common terms with the lowest power. So we are saying common terms, it is 2, 3 and the lowest powers they are 1 and 2, and the answer you will get, it is 18. Or second method we have is, you will start dividing 540 by 126 till you will get the remainder 0. Whatever the answer you will get over here, that will be 18. So that procedure you can also use. So it is up to you that how you want to solve these type of questions. You can use any one of these two methods. Next is find the largest number that will divide 398, 436 and 542, leaving remainder 7, 11 and 15. So again as we have discussed in the previous cases, our question will become that we have to find the largest number that will divide 398 minus 7, 463 minus 11 and 542 minus 50. So these values, these are 391, 425 and 527. So our question becomes that we have to find the HCF of 391, 425 and 527. So when we will find the prime factors of these numbers, we will see that if we try to find the factors of 391, 2 is not the factor, 3 is not the factor, 5 is not the factor, 7 is not the factor, then 11 is not the factor. You have to check whether 391 is divisible by 11. So how we check? We sum these two values, it is 4. Then we have to subtract it from 9 and we will see the answer is 5. So we are saying that it is not divisible by this number 391, it is not divisible by 11. Similarly, in the next step you will see that it is not divisible by 13, it is not divisible by then the next prime we have, it is 17, and then you will find that it is divisible by 17 and the answer you will get, it is 391 is equal to 17 into 23. Similarly, for the next question, we are saying that if you will do the prime factorization, you will get the answer is, for this we are getting the answer is 17 into 23. For the next we are getting it is 5 square into 17, and for this it is 17 into 31. So what we have is that HCF of all these three numbers, it is 17. So 17 is the largest number that will divide 398, 436 and 542, leaving remainders 7, 11 and 15 respectively. Now the next is two tanks contain 504 and 735 liters of milk respectively. We are talking about that we have two tankers. One contains 504 liters and second tanker contains 735 liters of milk. Find the maximum capacity of a container which can measure the milk of either tank an exact number of times. So suppose I am saying that we have a container of 1 liter. We can measure the capacity of this. We can measure the capacity of this exact number of times. Suppose I have the container of 2 liter capacity. It can measure the capacity of this container exactly, but it cannot measure the capacity of this container because 735, if we will start measuring the capacity of this, finally after 734 we will be left with 1 liter, and we cannot measure this 1 liter with this 2 liter container. So we want to find suppose I am talking about there is a 3 liter container. So we will see that this 3 liter container, it can measure the capacity of both these. So we have to find that what is the highest capacity of the container that can be used to measure the milk in both these containers exactly. So basically what we have to do is we have to find the HCF of both these values. So we are talking about the HCF of 504 and 735. So to find the HCF, we are doing the prime factorization over here. This is the prime factorization of 504. This is the prime factorization of 735. So we are saying 504 is 2 raised to power 3 into 3 raised to power 2 into 7, and 735 is 5 into 3 into 7 raised to the power 2. So the common values that we will have, common factors we have over here, it is 3 and 7, and their lowest power of 3 is 1, lowest power of 7 is 1. So HCF of both these is 21. It means if we consider a container whose capacity is 21 liters, it can be used to measure this exactly, and it can be used to measure the milk in this container exactly, and this is the highest capacity of the container that can measure both these values exactly. Now in this next question it is given that 612 members of army, they have to march behind the 48 members of the band in a parade. So the two groups means we are talking about these army men in the band, these are the two groups we are talking about, are to march in the same number of columns. What are the maximum number of columns in which they can march? So what we mean to say from this question is, if suppose 48 persons of army band are there, what they can do? We are saying, suppose we are representing them with these circles. I am saying that what they have done is, they have made say 24 columns and 2 rows. They have made 24 columns and 2 rows. Now 612 members of army, they have to march behind them. What will happen? 24 are there, then next 24 are there, next 24 are there. So if we look at this value, what we see is that 612 divided by 24, if we look at, what we see is that there the answer that we will get, it will be 25.5. It means how many rows we have to find? It is 25, and then some of the army men will be left and they will not be filled completely in the columns. Now suppose in place of this I am saying that they are moving like this in say 3 columns. So how many rows of the band will be formed? It is 48 by 3. And how many, after this we have to place the army men over here, and how many rows will be formed? It is 612 by 3. So we have to find the maximum number of columns in which they can march. So for the maximum number of columns, it means 3 is sufficient, 24 will not work. If suppose I am talking about 4, it will work over here. So we have to find how many maximum number of columns that can work. So one thing we have to do is we have to manually check. We are saying suppose there is 2 columns, it will work. For 3 it will work. For 4 it will work. We have to check for 5, 6. So in place of this, basically what we are trying to find is, we are trying to find the HCF of 612 and 48. We are trying to find such a number over here. We are saying we are trying to find such a number over here which divides 48 also, which divides 612 also exactly, and that should be the highest number. We are interested in the highest number which divides both 48 and 612, and that is the HCF of 612 and 48. So these are the factors that we have shown over here, that what are the, how we are going to do the prime factorization over here. So prime factors of 612, we can write it is 2 raised to power 2 into 3 raised to power 2 into 17, and prime factors of 48 we can write it is 2 raised to the power 4 into 3. So HCF of both these values, if we look at, it is 2 raised to power 2 into 3. So the answer we will get it is 12. So we are saying that the required number of columns is 12. Now next is a sweet seller has 420 Kaju Barfis and 150 Badam Barfis. We are talking about, suppose these are the Kaju Barfis and these are the Badam Barfis that he has. We are saying these are 420 and these are 150. He wants to stack them in such a way that each stack has the same number. So he wants to put them in such a way that they have the same number. Stack them in such a way means, if he keeps, suppose if he starts keeping the Kaju Barfis we are talking about, if he keeps 150 over here, then 150 over here, then he is left with these burfis over here, that is 120 over here. Now if we are talking about these are the kaju burfis, it is 150 over here. Now first thing that we have to keep in mind is that each stack has same number. Now if he keeps 150 like this, then this stack over here it has 120 burfis. Now second thing we have to do is that they take up the least area. They take up the least area means one more thing that we can do is we just divide all these burfis as single part. That is, we are talking about the tray is there, and what he has done, he has just kept one piece like this, all 420 pieces like this, and then after that he has kept all 150 pieces like this separately. Then it will cover some area over here. We are saying the area covered should be minimum, and the area covered will be minimum. This area covered will on the base will be minimum if this height over here, that will be maximum. So it means what we want to do is we want to find a number that divides both 420 and 150, and that should be the largest number. We are talking about if suppose I find some number b that divide both these values, and I am saying the stack that I am forming that should contain these many burfis. So this is the largest number I am talking about. This is the largest number I am talking about. So one stack will contain b burfis, second will contain b, third will contain b. These their total will be 420. These are for the kaju burfis. Next, for the badam burfis, the same stacks will be formed with b quantity. Now the number of stacks that will be formed over here, that is 420 by b. This is 120 by 150 by b. The total number of stacks that we will have over here. These are the total number of stack. So this is what we have to calculate. So we have to calculate the highest number that divides both these values. It means that we have to find the HCF of both these numbers. So for HCF we are saying we have written the prime factor. We have done the prime factorization of 420. We have done the prime factorization of 150, and we have written the HCF of both these numbers. Highest common factor we are talking about, we have written that number, and the answer we have obtained, it is 30 over here. So we are saying that if we keep the size of the stack as 30, then we will have the maximum height over here with the minimum number of stacks, and this is what we have to calculate, that the maximum number of burfis in each stack is 30, and number of stacks that we will have, we are saying this is the formula we are talking about, the number of stacks that we will have in place of b, now we will have it is 30, and when you will calculate this value, you will get the answer is 90. So this is the answers, the values that we require. Now in this question it is given that Ravi and Shikha drive around a circular sport field. So a field is there, and they are driving around this. Suppose the starting point that we have, it is over here. This is the starting point we are saying, and Ravi takes 16 minutes to take one round. We are talking about this is Ravi, and after 16 minutes he has reached the same point, while Shikha completes the round in 20 minutes. Talking about this is Shikha, both of them they are moving on the same round. The Shikha completes the round in 20 minutes. So what this thing means is that after 16 minutes Ravi will reach over here, and Shikha will be somewhere over here. This is after 16 minutes. If both start at the same point at the same time and go in the same direction, after how much time they will meet at the starting point? Now, suppose I am talking about after 16 minutes, this is the situation. Now, after 32 minutes, what will be the situation? We are saying after 32 minutes, he will be at the same point. Now, Shikha will be somewhere over here. Now, suppose I am talking about after 48 minutes. Again, he will be at the same point. He would have completed 3 rounds. And Shikha will be somewhere over here on the third round. Similarly, if we keep on moving like this, then some situation will come after some time. A situation will come when both of these will be at the starting point. We have to calculate that value. So what we are saying is, we are talking about that we are calculating the least common multiple of both these values. That is, least common multiple means, if I am talking about the multiples of 16, I am talking about the multiples of 20. Why multiples? I am talking about this person over here. He will reach over here at this point at 16th minute, at 32 minute, at 48 minute, then at 64 minute, then at 80 minute, and so on. He will be at this point. If I am talking about Shikha, she will be at this point. I am talking about Shikha. She will be at this point. On which intervals? She is moving with 20. It is at 20th minute she will be here. Then 40th minute she will be here. Then 60th minute she will be here. And then 80th minute she will be here. It means after 80 minutes, both of them will be at this initial point. And what this 80 is basically, this 80 is basically the LCM of both these values. So we are saying that the required number of minutes is LCM of 16 and 20, and the answer of this value, it is 80. This is the manual way to calculate. This is just I am telling you that what this 80 is representing. This 80 is representing that they are moving in the multiples of, Ravi is moving in the multiples of 16 minutes, and Shikha is moving, reaching that point at the multiples of 20 minutes, and we are calculating the least common multiple. That is the first time that when they will meet, that will be the least common multiple of both the values 16 and 20. Next is, in a school there are two sections, namely A and B of class 10. There are 30 students in section A and 28 students in section B. Find the minimum number of books required for their class library so that they can be distributed equally among students of section A or section B. Now we are saying in section A there are 30 students. In section B there are 28 students. Now we have to find the number of books that can be distributed equally among these all students. So if we have to distribute the books, it means the minimum required books, that is 30. And if there are 30 books in the library, they will be distributed equally among them. But for these students, we are saying 2 books will be left. They cannot be distributed among these students. Next, suppose we are saying 60 books we have. Again, For these students, these 60 books cannot be distributed equally. So what we are trying to find over here is that suppose n books are distributed to these students and m books are distributed to these students. It means total number of books that should be, that is 30 into n should be equal to 28 into m. Both of these values should be equal. So what we are trying to find is, we are trying to find the multiples of 30 and 28. I'm talking about the multiples of 30. It is 30, 60, then 90 and so on. Similarly, I'm talking about the multiples of 28. If we ask for the books as a multiple of 28, it is 28. Then the next value, it is 56 and so on. So we are saying that what is the least common multiple over here? These are the multiples of 30. These are the multiples of 28. Then we will have some common multiples over here. When we will collect all these values, we will have some common multiples over here. And the minimum of all these common multiples, that is LCM we are talking about, that is the LCM of 30 and 28, that is the number of books that are required in the library so that they can be equally distributed among the students of section A or section B. So to calculate the LCM of these numbers, we have written 30 is equal to 2 into 5, 3 into 5, 28 is equal to 2 raised to the power 2 into 7, and LCM of 20 and 28 will be product of prime factors with highest power. So the answer that we will get, it is highest power of 2 is 2 raised to power 2, then it is 3, then it is 5, and then it is 7, and answer we will get, it is 420. So we are saying the required number of books is 420.